Welcome to the video presentation of our mini project, that is music equalizer implemented on DSK 6713 development board. Myself Pradeep, I am going to introduce the concept of equalization, and my project mate Divakar will explain the implementation of equalizer on DSK 6713 kit. And finally, my another project mate Vishwesh will demonstrate the working of our project. Let me move on to the introduction part. Equalization. Equalization is the pre-processing step employed in the audio recording. Equalization is formally defined as the process of increasing, that is boosting, or decreasing, that is attenuating, the strength of certain band of frequency in the audio spectrum. The rest will be explained by Divakar.
Now let us study what is the need of equalization. Usually when the sound is recorded and reproduced in an electronic system, the reproduced sound may not be resemble as the original sound. This is because the frequency response of the recording microphone and the reproducing audio power amplifier is not flat in the audio frequency range. Hence, some part of the audio spectrum is attenuated and only some part is reproduced as it is. To compensate for this, here you can observe in the figure, in the first figure we obtain the flat, that is ideal response, and in the second figure we have obtained non-flat, that is while recording in microphone we will getting this type of response for an amplifier. To compensate for this, we will go for equalization. Usually, to compensate for the microphone loss, the equalization is done during recording and to ensure for faithful reproduction of the sound during playback, and to compensate for the non-flat frequency response of amplifier, equalization is done prior to amplification. In our design to achieve equalization, we divide the audio frequency range into three bands, namely low frequencies, that is bass, mid frequencies, vocal, and high frequency, that is treble. And the frequency range we are using for the for the bass is 500 Hz, and for vocal it is ranging from 500 to 1.5 kHz, and for high pass filter it ranges from 1.5k to 20 kHz. For low frequencies we have designed a low pass filter of cutoff frequency 500, and for mid or vocal frequency we use a band pass filter having a band from 600 to 1.5 kHz, and for high pass filter we use high pass filter with cutoff 1.5 kHz. The scalars A, B, C, that is the weights assigned to the output of each of filter, this will going to decide whether we have to attenuate or providing a gain to the amplifier. After doing these linear combinations, we are finally summed up if we are taken the scalar A, B, C in the range 0 to 1, it will attenuate, and if we take the scalar values which is greater than 1, it will provide gain for the amplifier. The rest part will be explained by the Vishwesh, that is implementation part on DSK board.
Thank you, Divakar. As explained by my project batchmate Divakar, as you can see in the figure, the output of each filters, that is low pass filter for designed for bass frequencies, band pass filter for vocal frequencies, and high pass filter for treble frequencies. Each output is denoted as YL of n, YV of n, and YT of n respectively, with the associated scaling factors A, B, and C. As he mentioned earlier, if these scalars range between 0 to 1, those particular band of frequencies or the output of those particular filters either will be attenuated. If it is equal to 1, they are passed as it is, and if the scalars are greater than 1, they provide gain to those particular frequencies, band of frequencies. So finally the music contains all these bands of frequencies which makes up the audible frequency range. So let's move on to the next slide. Here we have designed our equalizer on the DSK6713 kit, and we have already assigned dips for different combination of dip switches, the different combination of bass, vocal and treble frequency contents. So if we choose scaling factor ABC equal to 1, then we will get flat or normal frequency response. So if the signal is passed through the preset normal, all the frequency contents, that is bass, vocal and treble, are weighed equal to 1. So all the frequencies will be enhanced, that is normalized. So first we need, while observing the video, we should look at the combination of dip switches. So we have assigned, so these are the dip switches present on the DSK6713 kit. This is assigned as MSB, and this dip switch is LSB. So if this switch is made high and the rest of the switches are low, then it is equivalent to 8 1000. That is the binary equivalent is 8 in decimal numbers. So that combination is assigned with normal preset, that is all the scaling factors are equal to 1. And then if all the switches except for this LSB switch is made high, then that particular combination is assigned with bass, that is bass frequencies are enhanced, the scaling factor associated with the bass filter, that is the low pass filter A, the scaling factor is greater than 1, and all these vocal, the output of the band pass filter, that is vocal frequencies, and the output of the high pass filter, that is treble, B and C, both the scalar values are made less than 1, so those frequencies are attenuated. And similarly the next LSB bit is made high and rest all other bits are made 0, then though that particular combination results in 2 0 0 1 0, that is the equivalent decimal equivalent, that is 2. So that particular combination is assigned with low vocal. And for if the second MSB bit, that is this switch is made high and rest all the switches are made low, then it corresponds to the combination equal to 4 1 0 1 0 0. So that corresponds to 4. So that in that combination the high pass filter output is weighed high compared to vocal and bass frequencies. So these are attenuated and only the treble is enhanced. While watching the video, we should notice the changes that happen to the sound output of the kit when we change the combinations. Let's look at the video. This is for normal, so this bit is made high and all the rest of the bits are made low. So let's look at the video. can see this switch was made high and all the other switches were low, and that corresponds to the normal. So you can notice the music which contains all the frequencies, treble, bass and vocal. So next combination is the LSB bit is made high and the rest of the switches are made low. So this corresponds to 0 0 1, that is equal to 1. So here you can notice the bass, only the low frequencies are emphasized compared to vocal and treble frequencies. So the scaling factors associated with vocal and treble are made in between 0 and 1. So let's look at the bass demonstration. So, and we will next move on to the vocal. Here the output of the band pass filter is weighed more compared to the bass, that is a low pass filter, and the high pass filter. The scaling factors associated with bass and treble, that is A and C, are in between 0 and 1, and the vocal is greater than 1. The scaling factor is associated is B, so it is made greater than 1. So let's look at the demonstration. So you can see in the video demonstration that only the voice is emphasized and all the other musical instruments were not present actually. They were attenuated to a greater extent as the scaling factors are made in between 0 and 1. So next we will move on to the high pass frequencies. Those are the treble frequencies. So only the treble is enhanced and all other vocal and bass components are suppressed to a greater extent. So this scaling factor associated with the high pass filter is C, that is made that particular scalar's value is made in between 0 and 1. Excuse me. So the output of the high pass filter, the scalar factor is C, that is made greater than 1, and all these bass and vocal low pass and band pass filter output scalar values are between 0 and 1. So this corresponds to the full treble, that combination. So let's look at the video demonstration. So as you can notice in the video that the sound output changes. So all the bass frequencies and vocal frequencies were suppressed to a greater extent and the treble frequencies were enhanced. The treble frequencies are the high frequencies that corresponds to the jingle sound in the music. In this way we can either increase or decrease the strength of a particular band of frequencies using equalizer, so to compensate for the non-flat frequency response as earlier mentioned by my project batchmate. So in this way we can achieve the equalization and we compensate the losses for the amplifier or microphone. So this concludes the presentation. Thank you.